How do you implement a Spring Boot REST API which you can use to store items in the database? I've done this countless times as a senior developer, and in this video, I'll show you the process that I use. This is part 6 of the event ticket platform build. There is over 4.5 hours of free content on this build here on YouTube, so I'll link to parts 1 through 5 below if you haven't seen those. Although, if you just want to learn how to implement a create endpoint in Spring Boot, then you can treat this as a standalone video, because that's exactly what you'll learn. All of the resources that I referenced today, including the Spring Boot source code and the React source code, you can download for free from the Devtiro Discord server. I'll put a link in the description below so you too can join the community. Okay, with that covered, let's get started. In this lesson, we'll implement the service layer logic to create events in our application. So back in our IDE, we've already declared that we have an event service. So let's, inside of the services package, create a new subpackage called impl, a convention that you'll often see, and it allows us to collect together all of the implementing classes for our interfaces. And within impl, I'm going to create a new Java class called event service impl, and it's going to be a Java class. And event service impl implements the event service. So let's expand this. And if we hover over here, it will tell us that we have a red squiggle because we haven't implemented the methods declared inside of our event service, namely create event. So we now have our create event method stub. Before we go any further, I'm going to add the @service annotation to the top of this class. I'm also going to add the @required args constructor annotation to the top of this class. The top one marks this class as a service, which will allow us to inject dependencies and also make event service impl available to inject whenever we declare an event service or an event service impl, but will typically declare the interface. And required args constructor, this comes from Lombok, and it will generate a constructor for us based on any instance variables that we specify here that are final. And that gives us a nice clean way to create a constructor, which will then inject these dependencies for us. So we've decided that we're going to use this organizer ID rather than passing about a user object. So we're going to need we'll say private final user repository. We'll call that one user repository. We're going to need the user repository to look up these users. So inside of our create event method here, I'm going to say user repository dot find by ID, this one here, passing in the organizer ID. And I'm going to assign that to a variable, which I'm going to call organizer. However, I don't want an optional here, so I'm going to delete the optional type. And instead, I'm going to handle this here and now. So I'm going to say or else throw. So in the case that the user was not found, we're going to throw a new user not found exception. And we'll put the message in here, string.format, I think. Put that on a new line. And we'll say something like user with ID, and then we'll do a %s to represent a string. User with ID, the ID not found. And then we'll need to pass in the organizer ID. And even though the organizer ID is a UUID, that seems to have worked. Okay, great, perfect. So within the user not found exception, we have the ID of the user that's not found as a message. So we now have our organizer user, or we throw a user not found exception. And we're going to need this organizer in order to create these entities. Let's create ourselves an event entity. So we'll say event to create equals new event. And let's, in fact, open up event and let's stick that on the right-hand side. Great, okay. So we're not going to specify an ID because the way that we've set up our entity, it will generate one for us. We are going to specify the name. So we're going to say event to create dot set name, passing in event get name. So event, of course, is our create event request. So we're going to pass in the name from there. And this is going to be the general pattern that we're going to follow. So we've just done name. Let's now do start. Event create dot set start equals event dot get start. We'll do end. Event create dot set end event dot get end. Venue. Event create dot set venue equals event dot get venue. And now sales start. Event create dot set sales start equals event dot get sales start. And now sales end event to create dot set sales end equals event dot get sales end. And now for status, event to create dot set status, and that's event dot get status because we're using that enum throughout. And now our organizer, which we've loaded up here. So event to create dot set organizer is the organizer user. And now we have attendees, which defaults to be a new array list. That's fine for us. Staff, again, new array list. Ticket types. We should set ticket types because that's provided in our create event request object. But they're complex objects in their own right. So if we go through ticket type, in fact, before we create our new event, let's say event.getTicketTypes.map, or stream.map, should I say. And this is our ticket type. Let's just pull that over for the moment so we can see. Great. Okay, so we're mapping over the ticket types, which are create ticket type requests. We're going to create a new ticket type object. So we'll say ticket type, or the convention we're following is ticket type to create equals new ticket type. And now we need to start setting the values on ticket type, which we just pull that over a little bit. We should be able to work our way through. Scroll that way. Okay. So the first one is going to be the name because we're not setting the ID. We'll have that generated for us. Ticket type to create dot set name is going to be ticket type get name. Next is going to be price. Ticket type to create dot set price is going to be ticket type dot price. It seems we've made an error on the set name. We should be loading from ticket type and not ticket type to create. Okay, so we have loaded the name, set that, loaded the price, set that. Now for the description. Ticket type to create dot set description, ticket type, get description. And now total available. Ticket type to create dot set total available is ticket type, get total available. So we have our event, we have our tickets, created that, updated that. So that should be it for the moment. So let's close this so we can see what we're doing. Close all tabs and group. And we're going to do to list. And of course, we need to return the ticket type to create at the end of that lambda, which means we can then assign this whole block, which we'll call ticket types to create. Great. So we have a list of ticket types. What we can now do is say event to create.set ticket types, paste that in, ticket types to create, and we can rely on any cascades to create those for us. Now, let's just go to the event object. We've done ID, we've done name, start, end, venue, sales start, sales end, we've done status, we've linked the organizer user that we've loaded. We're not going to do attendees staff because they don't even come into the equation yet. Ticket types. We've just set ticket types. We're not going to set created at or updated at because we're relying on our JPA order annotations to do that for us. And then the rest is just equals and hash code. So that looks like we have populated the event to create. So all that's left for us to do now is to save this. But currently we have no way of saving it. So if we go over to our repositories package on the left here, create a new Java class, and we'll call this one event repository, and it will be an interface. We're going to follow the same approach that we've done for user repository. We're going to extend JPA repository. Let's just maximize this. We need to specify the type, which is going to be event. That's our entity. UUID is our ID type. We'll put the at repository annotation on the top here. And we now have a event repository to use. So we can go back to event service impl, scroll up. We'll say private final event repository. We'll call that one event repository. Let's import this. Perfect. And now at the bottom of our create method, we can call event repository.save, passing in our event to create, and then we can call return. Because of course, save returns the object that it's just saved, complete with all of the values that it's generated, ID, created at, updated at. Okay, and with that done, that's our first implementation of our create event method. So in summary, we've created the event repository interface, and we created the event service impl class, and we've implemented the create event method. So now that we've implemented our service layer, let's create the DTOs and Mappers that we're going to use in our presentation layer. So back in our IDE, let's create those DTOs and Mappers that we can use to model our REST API. So within a domain here, we're going to create a new subpackage, and I'm going to call this one DTOs. And within DTOs, I'm going to create a new Java class, and I'm going to call this one create event request DTO. And this is going to be a class. Now you might be wondering why we are creating a create event request DTO when we already have a create event request, which looks like this. There is a couple of reasons for that. The create event request, I expect that to be used in the service layer, whereas the create event request DTO, I expect to be used in the presentation layer. And because the create event request DTO represents exactly what the REST API expects, I don't want changes to the create event request to impact the create event request DTO and vice versa. I want them decoupled. So the convention that we're going to follow is anything with DTO after the name, you can expect that to be used in the presentation layer. Although largely, to begin with, both of these classes are going to be pretty much the same. So much the same, in fact. I'm going to split the screen on the right for create event request. Create event request DTO can be on the left. Let's just close project so we have some space. So to the top of create event request DTO, we're going to add @data, all R's constructor, no R's constructor. And in fact, I'm going to take everything right down to status, copy that, and paste it in here. That's not going to be all that will do though, mind you. We are using this object create ticket type request. If I control click through to this, it represents the bare minimum information to create a ticket type. We'll need a DTO for this as well. So I'm going to, inside of DTOs, create a new Java class called create ticket type request DTO. And it's going to be a Java class. Let's close project again, and I'll pull the DTO to be on the left. So to the top of the create ticket type request DTO, I'm going to add @data, all R's constructor, no R's constructor. And then I'm going to take all the instance variables and paste them in there. However, we're not going to stop there, because inside of our DTO, we're going to add some validations. Now, I don't believe that we included the validation dependency when we were going through the Spring Initializer, but not to worry because we can add it now. So let's open up our project. Let's go to our pom.xml file, which is here. Let's close project so we have some space, and we may just have to pull that over a little bit. So we'll do this just after our Spring Boot Starter web. In fact, I'm going to copy the Spring Boot Starter web dependency, but rather than Spring Boot Starter web, I'm going to include Spring Boot Starter validation. And if we click the little Sync Maven Changes button up here, we now have access to those validation annotations. So let's close our pom.xml file. We are back in the create ticket type request DTO. Let's pull that over. So we have our split screen again. There we are. So now let's add some validations to the top of these. We always want the name of a ticket type to be provided. So I'm going to use the not blank annotation to the top of this. And I'm going to say the message is ticket type, name is required. I'm going to add the not null annotation to the top of price. We always want a price. And I'm going to say the message for this one is price is required. I'm also going to add a positive or 0 annotation to the top of this. We certainly don't want a minus price. So the message for this one is going to be price must be 0 or greater. So we'll allow a 0 price, but certainly not a minus price. So for description, we decided that this was going to be optional, so I'm not going to add any validation to description. We may want to specify a maximum on there. However, we haven't nailed down what the maximum length of a description might be yet, so we'll leave that as it is. And the same for total available. We've decided that this could actually be nullable in cases where perhaps there's an infinite number of tickets available, perhaps for an online conference, for example. So that represents our create ticket type request DTO. So if we go back to our create event request DTO, and for symmetry, let's close this on the right. So we have our create event request on the right. We can say private list of create ticket type request DTO, and we'll call that one ticket types. We'll need to import list. Great. So I'm confident that we have everything from create event request in create event request DTO. So I'm going to close this, and let's now add some validations to create event request DTO. So for name, we always want this provided. So again, not blank. We're going to say the message is event name is required. For start and end, we've decided that these can be nullable. If we really wanted to refine this, we could make sure that the end date is after the start date. But for the first iteration, let's just get it working first so we can come back to that. So we'll not add anything to start or end. We always want venue information. So let's say not blank. And the message for this one is going to be venue details are required, or maybe venue information is required. Okay. Sales start and sales end, they can be nullable. Again, we may want to add some validation that end is after start if provided. We can get to that later. Event status enum. Let's say not null. We always want to make sure that's provided. So we'll say message event status must be provided. And then we have our ticket types. We want to make sure that at least one ticket type is provided, I think. I'm not sure that we've captured that anywhere, but I'm going to codify that in now. So we'll say message, at least one ticket type is required. And I'm also going to add the @valid annotation, and that will activate any validation annotations within the create ticket type request DTO nested class, of which we have some. So that looks like our create event request DTO done. Now, the convention that we're going to follow for this particular build, on the basis that it's probably going to have a rather complicated REST API, is that we're going to model the requests separate from the responses. And we'll very rarely use a generic DTO in the presentation layer. So with that in mind, we should create the create event response DTOs now. These will be very simple, and they won't require any validation because they'll be on the return path. So let's open up project. And inside of DTOs, I'm going to create a new Java class, and I'm going to call this one create event response DTO. And it's going to be a Java class. And we'll expand this. We'll say @data, all R's constructor, no R's constructor. Now, what are we going to populate inside of the create event response DTO? Well, it's largely just going to be the same as our event entity, more or less. So let's bring up the event entity. We'll put that on the right-hand side. Create event response DTO on the left. Let's scroll up to the top here. So we definitely want the ID to be in the create event response body. We definitely want the name of the event, the start time if it's been provided, the end time if it's been provided, the venue, the sales start time, sales end time, the status. I'm going to choose to omit the organizer. We'll not include the organizer information. And there's no point including attendees because there won't be any. We've just created the event. Same for staff. We should provide ticket types though. So let's create a DTO separate for that. So over in DTOs here, we'll create a new Java class called create ticket type response DTO. Pull that to the left, close project. And if we were to control click through to ticket type to see the ticket type entity, okay, so let's put the @data, all R's constructor, no R's constructor on the top of create ticket type response DTO. These names are getting quite long. Let's do the ID in there, the name of the ticket type, the price of the ticket type, want the description of the ticket type, the total available, and we'll omit event because we already have that information. We don't want it nested again. Tickets, we'll omit that because there's no tickets associated with the ticket type yet. Perhaps we will include created at and updated at. There we go. So that's our create ticket type response DTO, which if we close the ticket type on the right and the create ticket type response DTO on the left, we can now use, that's our request, close that one. We can now use our private create ticket type response DTO list of, so list ticket types. Great. So that deals with this particular field in our event mapped to our create event response DTO. Let's also include the created at time and the updated at time. Perfect. Great. Okay. So with that done, we now have DTOs to represent the create and the response. Let's wrap up this lesson by creating the mapper for them. So within Devtiro tickets, I'm going to create a new package called Mappers. And within Mappers, I'm going to create a new Java class called Event Mapper, and we'll make this an interface. And let's expand this. So to the top of Event Mapper, this is going to be a map struct mapper. So the convention used here is to specify the mapper annotation. The component model is the string Spring. The unmapped target policy is going to be reporting policy dot ignore. Ignore anything you can't map. And now we can specify some methods in here. So this one is going to return a create ticket type request. So in our service layer, that object. And we'll call this one from create ticket type request DTO. Although I wonder if we can get away with just overloading them from DTO. And then we can specify the create ticket type request DTO as the DTO there. So we need to call this in our create endpoint method to take the response body and convert it into the create ticket type request, which we can use in our service layer. But of course, the create ticket type request is a nested object within the create event request. So we'll do the same thing from DTO. Hopefully MapStruct knows how to deal with that. Create event request, and we'll call this one DTO. So that should map the create event request DTO, let's import that, to the create event request. And then we want to do on the response side of things, we want to return a create event response DTO, and we'll say to DTO, passing in the event. Because the event's what we're going to get back from our service layer after I create. And the create event response DTO contains a subset of the information in the overall event. So that should work, MapStruct should know what to do with that. So with that in mind, we have DTOs for both the create side of things, the response side of things, and then we have a mapper to go from one to the other. So in summary, we created the create event request DTO. We created the create event response DTO. We created the event mapper interface. And the DTOs make use of validation annotations to ensure data consistency. In this lesson, we'll create the event controller and the endpoint callers can use to create events. So we're back in our IDE. Inside of com Devtiro tickets, we're going to create a new package and we're going to call this one controllers. Within controllers, we're going to create a new Java class and we'll call this one event controller. And let's expand this. So to the top of the event controller class, we're going to add the REST controller annotation. We're also going to specify a request mapping. We're going to specify the root or the base path of this controller, if you will, and it's going to be /API v1 events. So all endpoints on this controller, their paths are going to start API v1 events. I'm also going to add the required R's constructor to the top of this class as well. And that will allow us to inject the, we say private final event mapper. We need that certainly. And then the private final event service, which we'll call event service. So we now have access to our event mapper and our event service. So let's create a new public method, which will return a response entity wrapping a create event response DTO. And we're going to call this endpoint create event. Now, before we go any further, let's put the post mapping annotation to the top of this endpoint method because we're going to be using HTTP post. With that in mind then, let's inject a few things. Let's get hold of the JWT, so the token that's been passed by the caller. Bearing in mind at this point, it's already been authenticated. So we're going to use the @authentication principal annotation from Spring Security for this. And we'll say JWT because that's going to be the type of the principal, noting it comes to us from security auth2 JWT. And we'll simply call this one JWT. We'll also need to get hold of the request body. So we're going to say @request body. And the request body is going to contain a create event request DTO. And we're going to call this one create event request DTO. We're also going to put the @valid annotation before that to make sure that we have ourselves a valid create event request DTO that those validation annotations have been activated. So we have a JWT, a create event request DTO. I think that's actually all we'll need for the moment. So let's get to implementing this method. So first of all, let's convert the create event request DTO to a create event request, which we can use in our service layer. For that, we're going to use the event mapper. Event mapper dot from DTO, certainly doesn't matter which one we select really, as long as we pass in a create event request DTO, so the argument to the method here. We can assign that to a variable, which we're going to call create event request. Next, let's extract the ID from the JWT. So we'll say JWT dot get subject. That will return a string. So we're going to have to do UUID dot from string for this. Perhaps we'll extract this out into a utility or something like that. It feels a bit uncomfortable to do it each time, but this should then represent the user ID. So or perhaps better put, the caller user ID. Now we're going to assume, for the sake of the implementation for the moment, that the caller of the REST API endpoint is also the organizer of the event. We could potentially extend it in future for the user to be able to specify other users as organizers, but not for the first iteration. So we have ourselves a create event request and the user ID in UUID format. So next, let's call the event service dot create event, passing in the user ID as the organizer ID and the create event request. Now, if we assign this to a variable, this is our created event. Now, it should be noted that create event does throw an exception. In fact, I'm sure it probably throws several exceptions, but the one that we care about at the moment is the user not found exception. We'll handle that in the upcoming lessons. So we now have ourselves a created event. So let's get a response object. We'll go event mapper dot to DTO, passing in the created event, and we'll assign this to a variable which we'll call created, or perhaps for consistency, we'll just call it the create event response DTO. And now we'll return a new response entity, passing in the create event response DTO. And I'm also going to specify the HTTP status of created, HTTP 201. And with that, we have our initial implementation of our create event endpoint. So in summary, we've created the event controller class, and we've implemented the create event endpoint. At this point in the build, we should be aware of two things. The first one is that the user interface expects any errors in a very particular structure. And the second one is that we have a few exceptions that we're not handling that we should. So in this lesson, we're going to create a global exception handler to handle those exceptions, returning them in the accepted format. So here we are back in our IDE. Let's head over to our controllers package, and we're going to create a new Java class, and we'll call this one the global exception handler. Great, and let's expand this. So this class is going to handle all of the exceptions that we define that bubble up to the top. And then we'll get to control what the responses look like from our REST API. So to the top of this class, I'm going to use the @REST controller advice annotation. And I'm also going to use the SLF4J annotation. This top one tells Spring that it should look here in order to find how to handle certain exceptions. And we could also specify controller advice. That's completely reasonable. But as we have built a REST API here, we're only going to be returning data structures and not pages. We're going to use the REST controller advice annotation. SLF4J annotation, that comes to us from Lombok and allows us easy access to a logger. Because if we get an exception, it makes sense that we want to put that in the log. There's a few exceptions that I have in mind that we should handle, but I think we should start with just the generic exception class. So I'm going to say public response entity, and here we'll need to specify actually the structure that the user interface expects for all errors. So let's go to our project on the left here. We'll go to DTOs, and I'm going to create a new Java class, and I'm going to call this one error DTO. And let's expand this. This is going to be a very simple class indeed. We're going to add @data, all R's constructor, no R's constructor. So error DTO is only going to have a single instance variable, private string error. So this will return any error as a very simple JSON object with the key of error, and then a string which describes the error. So with this created, we'll go back to the global exception handler. The error DTO becomes the type in the response entity, and we can name this method handle exception. And the method is going to take just a exception class, we'll call that EX. So this is a general pattern that we're going to follow. We're going to log.error, and we'll say something like caught exception, and then we'll pass in the exception. Then we'll create an error DTO. So we'll say error DTO equals new error DTO. Then we'll say error DTO dot error, or set error, should I say. For this generic exception, we can't really give too much information. So we'll say in the string value, something like an unknown error occurred. We don't really want to pass information about the exception in the message. We don't want to leak internal state, internal details. So we just have to say an unknown error occurred, but we are logging the exception in the logs, part of the reason that we're doing it there. So we now have our error DTO. Let's go about returning it to the user. So we're going to return a new response entity, passing in the error DTO, and we'll go with a HTTP status of internal server error. Now there's one thing missing on this method to complete it, and that's an annotation. We need to add the @exception handler annotation, and we're going to specify the exception class. There we go. So let's move on to some more specialized cases. So our validation annotations are going to throw one of two different types of exception depending on where we've used them. We'll cover both just to be on the safe side. So the first one is the constraint violation exception. So we'll say public response entity of the error DTO type, and we'll say handle constraint violation. There we go. And we'll pass in the constraint violation latent exception coming to us from Jakarta validation. We'll call this one EX. There we go. Now, before we forget, I'm going to put the @exception handler annotation on the top, specifying the constraint violation exception from Jakarta validation .class. Great. So the body for this one is going to be fairly similar. I'm just going to copy this and put it up here. I'm going to change the message to say the particular type of exception that was thrown, or caught in this case, should I say. However, for the error message, we can do a bit better now that we know the type of the exception. So we're going to say EX, which is a constraint violation exception. And we can say get constraint violations, which is a set of constraint violations. We're then going to stream. I think in this particular case, we'll just return the first one. So we'll go find first, and that will return an optional. Let's start putting this on new lines. That will return an optional, so we need to map. And then we'll say violation as the argument type, violation dot get property path. There we go. And then we'll concatenate this. So there's some very particular fields that we want in our message. So the property path, so where the violation has taken place. And then we'll say violation dot, is there a message? Yeah, get message. Let's put that on a new line. So that should be a pretty good error message. Now we're returning the details from the violation. However, this should be safe. This is helpful to the user and shouldn't expose any internal implementation details. We'll say or else, and we'll put a message in there like a constraint violation occurred. So let's assign this to a variable, which we'll call error message. And now we can pass this error message into error DTO.setError. And I think rather than internal server error for this one, we're going to return bad request because the user has provided a request body that doesn't meet our requirement. So therefore HTTP 400 bad request. So that's the constraint violation exception handled. Now the other exception that we should handle is the method argument not valid exception. So we're going to say public response entity error DTO, and we'll call this one handle. Here we go, method argument not valid exception. And then we'll need to pass in the method argument not valid exception, and we'll call that EX. And again, before we go any further, I'm going to copy that rather than type out again. And we're going to say exception handler, method argument not valid exception dot class. So what about the implementation for this one? Well, I'm going to take the handle exception for the generic exception, because it's a pretty good starting point. And we'll say caught method argument not valid exception. We're creating a new error DTO. How do we create the error message for this one? Well, this one works with binding results. So we need to do ex.get binding result. Let's just assign that to a variable called binding result. And then we can say binding result dot get field errors. I think there's a, yep, there it is. That'll give us a list of field errors, which if we assign that to a variable, we can see. And I think we'll just return the first one again. So something like field errors dot stream dot find first dot map, and we'll say, we'll call that one field error. Great. We put this on some new lines. There we go. Field error dot get field, and let's just concatenate this with field error dot get default message. We'll need to do an or else for when it's not available, and we'll say something like validation, what we said for the other one, constraint violation occurred, we'll say validation error occurred. There we go. And if we assign that to a variable, which we'll call error message, fix that typo. So error message, we can now pass into set error here. And again, I think we'll return a bad request. So HTTP 400 for this. Okay, and there is one last exception that we should definitely handle, and that's the user not found exception, our custom exception that we're throwing. So for this, we'll say public response entity returning an error DTO, and we'll say handle user not found exception, passing in a user not found exception, which we'll call EX. And again, we'll add the @exception handler to the top here, passing in the user not found exception .class. And we'll scroll down to the bottom where we have the implementation for handle exception. Scroll to the top, paste that in. Great starting point. So what's the error message going to be for this one? Well, we could print out the message that we're passing in the exception, which is user with ID, whatever the ID is, was not found. But again, I don't want to leak that internal detail. So I'm going to set the message to be something generic. So we'll say user not found. Now, do we return a 404 or a 400? I think a 400. Bad request. Because this exception is going to be thrown by endpoints that have been given a user ID in order to do something. So in our case, create an event. Therefore, if we turn a 404, that's a 404 associated with the event web resource, which doesn't make sense because it's not the event that doesn't exist, it's the user. So we'll go with a HTTP 400. A bit abstract, I appreciate, but I think HTTP 400 fits us here. For the sake of consistency, we'll say user not found exception, caught user not found exception. So with this done then, we should have handled our generic exceptions and everything that extends it. But in more specialized cases, the constraint violation exception, the method argument not valid exception, and our custom user not found exception. So in summary, we created the error DTO class, and we created the global exception handler class. And now all errors are now returned in the expected format. So now that we've implemented the first iteration of our create event endpoint, let's try it out by calling it from our user interface. So here we are back in our IDE. Now, before we can call the REST API via the user interface, we need to run our Spring Boot application. If you haven't already, now is the time to start your Docker Compose environment. I'm going to do that with Docker Compose up. Okay, everything looks to have started successfully, so let's minimize this. Now, the next step is that we'll want to run clean compile with Maven. So if we open up the Maven panel on the right here, we can run clean compile. Now, the reason for this is that we're using Mapstruct and Lombok, and they generate code for us. I've experienced some issues if we jump right to running the application, but if we run clean compile, all of those issues go away. I suspect this has to do with some of the generated code being stale if we jump straight to running the application. But let's run clean compile. Build success, looking good. Let's minimize this and close the Maven panel. So the next step is to run our backend application, which we can do with the green triangle up here, or we can go to the tickets application. On the left, we can click on run. Okay, the application's started, by the look of things, started tickets application, but we do have a stack trace here. Error relation events does not exist. Error executing DDL. So this is auto DDL, Hibernate trying to generate the tables for us. So if we scroll all the way up to the top, I wonder if there's a reason that we can't do this. Error relation events does not exist. Let's keep going. Same again. Events does not exist. Okay, pretty consistent error message, but it doesn't tell us a lot. Because events, of course, should be generated by AutoDDL just like anything else. Haha! Syntax error at or near end. Where have we used end? We've used end inside of our event entity, which would make sense. Why we're seeing the events relation does not exist if the events table failed to create. Is there any more information that we can go on? Error executing DDL. Syntax error at or near end, which is here. Okay, I suspect end is a reserved keyword in Postgres. If we were to minimize this and go over to our entities, so in domain and entities, go to events and expand this, we're using end as the column name. And we're using start as the column name here. I suspect start is also a reserved keyword, if I remember rightly. So here's what we're going to do. We're going to keep the name of the instance variables as start and end. However, I'm going to change the column name to be event underscore start and event underscore end. And I can't imagine event underscore start or event underscore end being reserved keywords. So with that done, let's open up the run panel once more, and I'm going to rerun. Great. Okay, so we have some output from Hibernate, creating the various tables, etc. that we need. And the application seems to have started up fine. Perfect. So just to double check that, let's take a look at the tables in AdMiner. So AdMiner is a service that we're also running in our Docker Compose environment, and it's going to allow us to view the database visually. So we have a PostgreSQL database here. We are connecting to it via the server name DB. And the reason for that is if we take a look at, let's minimize that, our Docker Compose environment, or Docker Compose YAML, should I say. The service name of our database is DB. And because we're also running AdMiner inside of Docker Compose, we're able to use this name to connect to our database. I'm also going to copy the Postgres password that we're using because we're going to need that. So the username is going to be Postgres. The password is the password that we just copied. Now let's log in. Looking good. So we're using the Postgres database. Great. And it looks like our tables have been created. We take a look at events here. There we are. So event end and event start. So we've been able to use those particular field names. We select data. There's no rows because we haven't created any events yet. Great. So with that in mind, let's open up our user interface. So I've navigated straight to /organizers, this being the organizers landing page. And I'm going to click on create an event. We're redirected to the login. So I'm going to log in with organizer and password, the user that we created. We've been prompted to change the password because it's not very secure, but this is okay. It's my local development environment. Obviously don't use the password in production. And here we are, create a new event form. So I'm going to open up the inspect and then we'll go networks panel and let's try creating an event. So we're going to not be very imaginative with this one. We'll say test event 1. For the event start and the event end, I'm just going to leave those blank. We'll do the bare minimum information for this one. Venue details, I think venue details we can leave blank as well then. Event sales start, end, we can leave that blank. We do need to provide a ticket type. So let's say ticket test ticket type 1. Price we'll do is 123. Total available 123. Description test ticket type 1. Description. Let's actually change total available to be 456. So it's different in value from our price. Click on save. Test ticket type 1 has been added and we'll keep it in draft mode for the time being. So let's try out creating our event. Okay, so we have an error and an unknown error occurred. We get a HTTP 500, although the payload looks like it's okay. Test ticket type 1 description, test ticket type 1, 123, 456, the venue is blank string. So what could be going wrong? Let's take a look at the stack trace inside of our backend application. So back in our IDE, let's go to the run panel here. That looked blank to begin with. Let's just scroll down. Okay, that is certainly a stack trace. Let's see what we have. We scroll up. No resource found exception, no static resource at API v1 events. No static resource. This generally happens when we are trying to hit a REST API that doesn't exist. A REST API endpoint that doesn't exist, should I say. but I'm certain that we specified this. So let's go over to the controllers, event controller, API v1 events, API v1 events. Okay, we've used the argument name params when it should have been path. So if we restart our backend application now, okay, that's the backend application started up. Okay, so let's head back to our user interface. Okay, so here's what I'm going to do. I'm going to make no changes whatsoever. I'm just going to click on submit again. Venue information is required. So this is an example of our global exception handler catching one of those validation exceptions and then giving us the information. So venue information is required. So we must have made this required and I've left it blank. So we'll say test venue details. And with that done, let's scroll down again. In fact, let's clear the networks panel. And now let's click on submit. 201. Excellent. So at the moment, the user interface doesn't redirect or do anything like that because that's where it is in its development. However, we do get a HTTP 201, which is exactly what we're looking for because that's the status for created. The response, let's take a look at the response here. We have an ID that's been generated for us. The name is test event 1, which matches what we can just scroll up a bit. There we are. So test event 1 matches the event name that we've put in here. The start and end are null, and that's because we haven't specified a start and an end. The venue details, test venue details, that's there. Cell start and end, they're both off, so they're both null. The status is draft, so the status we specify down here. And then we have ticket types. UUID has been generated for us. The name is test ticket type 1, that matches. The price is 123, that matches. Test ticket type 1 description. Yep, that's what we specified in there. In fact, we pull that down a bit. Test ticket type 1 description. Total available 456. And we have the created at and the updated at date times generated for us as well. That's true for both the ticket type and for the overall event object. If we wanted to doubly check this, we can go over to add miner. We can go select data now. And we now get some data in here. Although perhaps what's slightly concerning is that we get 2 entries. Organizer ID. Okay, so the details are the same and they've been made about a second apart by the look of things. If we go back to our user interface, I wonder if I got a bit trigger happy. I did. Okay, so I clicked it twice. That's my mistake. But in terms of the actual event being created here, it looks like, yes, the event has been created and that looks good. I wonder if we can see the organizer ID, actually. We haven't taken a look at the user in the database yet. So we've made a request and our user provisioning filter has created for us this user with this ID. This is when it's created and we have ourselves the email address of the user. This was extracted from the JWT and then the name of the user also extracted from the JWT, created at, updated at. They are our JPA audit fields. So it looks like our user provisioning filter is working as well. Now, for the sake of everything being complete, I'd like to see ticket types. Select data. Great. So we have 2 records. Again, I clicked twice by the look of things, but we have created at, ID, description, name, price total available, updated at. It's all there. The only thing that's not there by the look of things is this event ID. It's null. So let's just look at the ticket entity for one moment. Minimize that. Ticket type. I did say ticket entity, didn't I? I meant ticket type. That's what we're looking at, isn't it? Let's just double check. This is in the ticket types table. Yes, okay. Let's go back. So where's the event link here? Interesting. So it looks like I've missed off adding the event. Actually, that does make sense. Let's take a look at the service layer. Go into services, go into the event service import here. Let's pull that across. Okay, so we extract our organizer. We list our ticket types to create, and then we add the ticket types to the event. But what we haven't done is added the event to the ticket types. So let's cut that. Let's place that up here. And then we can do ticket type to create dot set event, passing in the event. Should I say the event to create? There we go. Now I wonder if we have to persist this event before we can set it on the ticket types. I think we'll have to double check that. Let's restart our backend application. Okay, that's started up fine. Let's try this out. So back in our user interface now, I think we should probably put in some different details just to make it obvious. Test event 2. This time we're going to keep everything the same, I think, for the test case. So we'll say venue details 2. Keep those all off. We'll add a ticket type and we'll say test ticket type 2, price 123 456. And we'll say test ticket type 2 description, save that. And then we'll keep it in draft, click on submit. Okay, HTTP 201, that's been created. Let's take a look at things in our database now. So I'm going to click on select data once more. We have a third record here. ID, created at, description, name, total available. Wonderful. So this one now has an event ID. So that link is there. So we click through to this. There's our event. Okay, so it looks like then we have an event being created successfully, linking to our organizer ID. So our organizer user. We have ticket types, we select data, being created successfully, and then linking through to our event ID. Great. Now I'd like to see a test where we provide all of the data. So back to our user interface. Let's just refresh this page. I'm going to go with test event 3. Event start. Let's specify, let's just pull this down a bit. So event start, let's say the event is going to take place on the 10th of May at 10 o'clock in the morning. The event ends at, let's say, 6 o'clock in the evening. Venue details, let's say online event. The event sales start. So let's say tickets go on sale on the 9th at, let's say, 1 o'clock. And tickets stop being on sale at, let's say, 6 o'clock. For the ticket types, let's say general admission. And the price is, let's say, 100. And the total available, let's say, 200. Description, let's say, access to event. Click on save. Great. Okay, and we'll say this is published. So I think that's all of the information provided this time. So all of the dates as well. So if we pull this up, clear this, and then we'll click on submit, 201. Let's make sure everything's in the payload. Okay, I'm seeing some dates. Start date, 10/6. Sales start, 1/6. Great. And then published. Okay, that's looking good. So let's head over to our database now. Let's start over on events, select data. Okay, so it's this last one here. We can see it has a event end date in there, name, sales end date, great. Sales start date, event start. This one's published, online event. It's got the organizer ID, which is linked there. Let's look at ticket types, select data. So this one at the bottom, created at, access to event, general admissions, 100, 200, updated at, and there's our link through to our event ID. As a last stop, let's just make sure there's no exceptions or anything in the logs. They look empty, but they're not. Let's scroll to the side. Okay, great. So we have the output from Hibernate doing its interactions with the database, but other than that, it looks like there's been no exceptions. So it looks like the first iteration of our create event endpoint is working as expected. So in summary, we experienced an error when attempting to save an event in the database. Start and end are reserved keywords in Postgres. So we updated the event object to no longer use the reserved keywords, and we've now been able to successfully create an event. So let's recall what we've achieved in the create event module. In UI overview, we've seen that the user interface can be used to create an event. A field name description has been added to the ticket type object. In create event design, we implemented the create ticket type request class and the create event request class. And we created the event service interface with the create event method. In user not found exception, we created an event ticket exception parent custom exception. We created the user not found exception to represent the invalid state when a specified user does not exist. In create event implementation, we created the event repository interface. We then created the event service import class. We implemented the create event method. In DTOs and Mappers, we created the create event request DTO class and the create event response DTO class. We created the event mapper interface, and we ensured that the DTOs made use of validation annotations to ensure data consistency. In event controller, we created the event controller class. In global exception handler, we created the error DTO class. We created the global exception handler class, and all errors are now returned in the expected format. And finally, in try it out, we experienced an error when attempting to save an event in the database. We established that start and end are reserved keywords in Postgres. So we updated the event object to no longer use the reserved keywords. And we have been able to successfully create an event in our system. We're now able to create events in the database. It's a pretty exciting place to be, because now we can start thinking about tickets and those QR codes. As a reminder, if you want free access to the Devtiro community, there is a link in the description below, and that's where you can download the source code that I've referenced here today. Now, if you look up here, you should see the next video in the series. And if you don't, it means it's not out yet. So I recommend subscribing to be notified when it does come out. And in the meantime, why not check this out?